Hello class, everyone. I hope everyone is fine. Today we are going to continue with covalent bonds and the topic being structure and bonding. Now, there's something which might be giving you problems on how we come up with these electrons here. So, I want to show you how we come up, for example, oxygen. You know that oxygen is 2,6. Like that, we have 2, then we have 6. Now, when we want to represent it in structure and bonding, we just take the one in the outermost energy level. That's why we are going to count the oxygen electrons to be 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. For example, we have maybe magnesium 2H2, 2, 8, 2. Now, when now we want to do the bonding, sometimes you just find that all these are excluded, you are just going to see only these 2. So, in bonding, especially in nanometers, we are just going to take these 2 outermost electrons. Like that if you see that kind of a thing, don't be scared or start wondering how it came out. That being said, in structure and bonding, always we want the elements to acquire the configuration of a number of gas. For example, in water, what is written as H2O. That means we are going to have 2 molecules of hydrogen and 1 molecule of water, of oxygen. So oxygen being here, hydrogen being here, another hydrogen being here. So what you do, 1, 2, 3, 4, 5, 6. So these are the electrons for oxygen. Then hydrogen will have 1, and this other hydrogen will have 1. So, for this hydrogen to acquire stability, it has to have electron configuration that is a duplet. In other words, it has to have 2 electrons. While for this oxygen to be stable, it has to have 8 electrons. And now, being that these are nanometers, there is not going to be complete transfer of electrons, but what's going to happen here? There's going to be sharing of electrons. So for balancing, or rather for stability of hydrogen, is always easy. You just take 1 oxygen electron from here, you put here, then that is gone. Then you take this electron here, you put here. Now, looking at this hydrogen, hydrogen already has 2 electrons that means it's stable. One is for himself, other one for oxygen. While this hydrogen is also stable, because it has 2 electrons around it, one from himself, the other one is from oxygen. So the one from oxygen has to be similar to the one here. Then, when now we come to oxygen itself, we have 1, 2, 3, 4, 5, 6, 7, 8. And now oxygen is also stable because the electrons around it are 8. Using a diagram, hydrogen has 1, is hydrogen. Oxygen has 1, 2, 3, 4, 5, 6. Another hydrogen here, 1. Now, what's happening? Hydrogen here will have to share. This circle is the one is going to represent sharing. Then another hydrogen here. Then this oxygen. For hydrogen here is for oxygen. Then for oxygen, Then hydrogen contribute 1 here, oxygen contribute 1. Such that if you look at the around oxygen 1, 2, 3, 4, 5, 6, 7, 8. Hydrogen has got 1, 2, Everything must go to. This is what represents the sharing between in water. And remember, for covalent bond, anytime we have a dot in the cross, this constitutes to a covalent bond, like this. So if we draw hydrogen here, we have an X and a dot here, an oxygen. Then we have an X and a dot, hydrogen. So when you see a kind of a dot, a dash here, that means we have a dot and an X. So that's been for water molecule. And I want you to be very careful because counting can also be a problem. Some chlorine. Chlorine, you know that it is 287. So we are just going to pick 287. So we are going to represent only the outermost energy level. So 1, 2, 3, 4, 5, 6, 7. Then another chlorine plus another chlorine. 1, 2, 3, 4, 5, 6, 7. Now when these two combine, they are going to share electron. This one needs one to be stable, and this one also needs one to be stable. What's going to happen? So this one will contribute this one here, this one will contribute. What am I talking about? Chlorine here. 1, 2, 3, 4, 5, 6. Then the one to be shared is going to come here. Then this one is also to be shared, comes here. Then we are going to make 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that if you count the number of electrons, it will be 1, 2, 3, 4, 5, 6, 7, 8. And if you come here also, 1, 2, 3, 4, 5, 6, 7, 8. After watching these videos, if you have any problem, you are supposed to text me through my WhatsApp number and ask any question. Now, this becomes a chlorine gas. Chlorine gas. Another way we can represent this, we can just use these ones. 1, 2, 3, 4, 5, 6. Then the shared one will be in the middle. Then we start 1, 2, 3, 4, 5, 6. Then we have chlorine here, we have chlorine here. Now, if you look at this can also be written. Remember, we just have one covalent bond there. So you want to have C, Cr. Because it is one, we cannot have more than one. So we are going to have just one dash there. The next one I want to look at is oxygen molecule. Oxygen is made up of, oxygen is 2 6. Oxygen is written as O2. That means you are going to have 2 oxygen molecules. We are going to have 2 oxygen molecules. So, we are going to have the first one. 1, 2, 3, 4, 5, 6. Plus another oxygen molecule. 1, 2, 3, 4, 5, 6. Now, we need this one to be count to be 8 and this count to be 8. So, the first one, after we are having this, if this one contributes, this oxygen contributes this electron, and let me just draw this way. I want to see how the share comes in. 1, 2, 3, 4, 5, 6. For this one here, plus 1, 2, 3, 4, 5, 6. This is another oxygen. Now, suppose this one contributes this electron here. We will count this one. Now this is gone. And this one also contributes 1, which is a dot. So if you count around this one, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Still, it's not balanced. This one also, this one contributes this one too. Yeah. And this one also contributes this one. Yeah. If you count, 1, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now, that means that for this one to be stable, then this oxygen has to give up 2 electrons, and this one also has to give 2 electrons. Such that if we rearrange them, and rearrange this one too, such that now we have how many covalent bonds here? We have 2. So we can write O, first covalent bond, we have the second covalent bond, and oxygen. So we can also write it that way. So one contribute one, the other one contribute another one. So there is sharing. In covalent, they share. One contributes one, the other one contributes the other. Now we are going to take a break at that point, and when we come back, we are going to see how nitrogen molecule is going to be made.